This is activity 3 from lesson 11, writing relationships from slope triangles. So we're going to use the relationships between these two slope triangles to write an equation. We know that the relationship, the ratio of the vertical length to the horizontal length is going to be 3/4. So this vertical length is going to be 3/4 this horizontal length. We're going to use that ratio and set that equal to the relationship of this vertical length to this horizontal length, which are written using x values and y values as expressions. So for a moment, I just want to get rid of this triangle and show you that the y value has to be written as y, this vertical length has to be written as y minus 1. You have to get rid of this 1 unit because this is moved up 1 unit along the y-axis. So you have to subtract that 1 unit to figure out what the y value, what the vertical length, is. So this is, if this is y, this length is not y. This vertical length is that y coordinate minus 1. This length right here is not the y coordinate, it's the y coordinate minus 1. You have to subtract that 1. And this length right here is not the y coordinate, it's that y coordinate minus 1. You have to subtract this 1. And the same down here. All right, so let's zoom in and look at the small triangle for a moment. So the length along the x-axis, the horizontal length, is the x-coordinate because this goes through 0. X is equal to 0 right here. So this length is whatever you write as the x-coordinate. But the vertical length is the y value minus this 1. So this goes up to about 2.5. But this length is not 2.5. You have to subtract this 1, and this length is actually 1.5. So it's 2.5. So the y coordinate would be about 2.5. Subtract 1, you get a value of 1.5 for this length. So the ratio is going to be y minus 1 to x. So that's the ratio. And so the ratio of the vertical length to the horizontal length, we know what that is as far as its value using numbers. It's 3/4 from this slope triangle. And this is similar to this, so they have the same relationship. So the vertical side is 3/4 of the horizontal side. Down here, this vertical side is 3/4 of this horizontal side. They have to have that same relationship. Well, if that's true, they have the same slope, but this relationship, you get this vertical length by taking the y coordinate and subtracting 1 from it. You have to get rid of this 1 and using the x coordinate as written because it goes through 0. You don't have anything to subtract. So it's this y or x coordinate minus this 0, so that's x, and it's the y coordinate minus this 1, so that's y minus 1. That ratio, what does that have to equal? It's the same as this similar triangle. It has to equal 3/4. So y minus 1, that ratio of y minus 1 to x, y minus 1 comes from subtracting that 1 unit right there, that equals 3/4. So in the second set of triangles, now you have to subtract both a value from the x-coordinate and a value from the y-coordinate. So the x-coordinate has been moved over 2 units. So you have to subtract those 2 units, whatever x is. To get the horizontal length, you have to subtract 2 units from it because it's been moved over 2 units. So you have to subtract them. Whatever the y-coordinate is, you have to subtract 4 units because this has been moved up 4 units. 1, 2, 3, 4. So the x-coordinate has been moved over to, actually the x-coordinate, the y-coordinate in this case is 4 So you have to subtract these 4 units to get to this triangle. So this y value has been moved up these 4 units. So this y minus this 4 is going to give you the length, this vertical length right here, subtracting these 4 units. The x value, you have to subtract these 2 units. So whatever this x value is, you have to subtract these 2 units, because this triangle, this relationship is starting here at coordinate at point 2, 4. So it's x minus 2, you have to get rid of these 2 units, and it's y minus 4, you have to get rid of these 4 units. So it's x minus 2 to get this length. So the length is not a little bit more than 4. The length is a little bit more, let's call it 4 just for a moment. The length is actually 4 minus 2. So this length is about 2 units. You have to subtract these 2 units. So this is the same thing here. So you go out, it's going up 4 units along the vertical length, and you have to move, imagine that you have to move this triangle over these 2 units. So this to here, and down 4 units to here. Well, moving it over 2 units is subtracting these 2 units from this x value, and moving it down 4 units is subtracting these 4 units from this y value. So it's y minus 4. This length right here is the total length minus these 4 units, and x minus 2. This length right here minus this length, right here, minus these 2 units. Now that relationship, this vertical length to this horizontal length, is the same as this relationship. So it's the same as 3 to 4. So the ratio of the vertical length to the horizontal length is, no, I don't like that I wrote y over x, but it's 3 to 4. So it's the length of y over the length of x is 3 to 4. So the vertical length is 3/4 the horizontal length. This vertical length is 3 units. That is 3/4 this horizontal length, which is 4 units. So that relationship, y minus 4 to x minus 2, is the same as this relationship, 3 to 4, or 3/4, the vertical length is 3/4 the horizontal length, equal to 3 to 4. So y minus 4 to x minus 2 is the same as 3 to 4. So we have now looked at 3 different lines, all with a slope of 3/4, but different equations. This one, the relationship is the length of y is the value of y, and the length of x is the value of x, because it goes through 0. You don't have anything to subtract. So this is the ratio of y to x is equal to 3/4. This one you have to subtract 1 unit from y. You don't have to subtract anything from x. So this is y minus 1 over x. That ratio is equal to 3/4. And the last one, you have to subtract 2 units from the x value, 4 units from the y value. So this is y minus 4 over the ratio of y minus 4 to x minus 2. You have to get rid of those 2 units, and that's going to equal this same ratio of 3 to 4. So 3 different lines, all with the same slopes. They're going up at the same slant, but they all have different equations. So this is activity 3 from lesson 11.